So the question is demultiplexer, which is asked for 6 mark. Okay. So you know that demultiplexer is opposite of that of your multiplexer, right? Where you will be having one input and n number of output. One input and many output, right? So how can you define a demultiplexer? Demultiplexer is a combinational logic circuit having a single input and many outputs. It performs the reverse operation of multiplexer, right? It accepts a single input and sends it to one of the output lines according to the select inputs. So in the case of demultiplexer, you will be having one input and your corresponding data in will be given to your corresponding output depending on your select lines, right? So suppose if you have S0, S1, etc. up till SM as your select line. If it is 0, 0, 0, then the input will be switched or will be given to your line Y0. If it is 0, 0, 1, then it will be your, you will be getting the output across your Y1. 0, 1, 0, you will be getting it across Y2 and so on. Okay. So it acts as a switching element. It accepts a single input and sends it to one of the output lines according to the select inputs. For n output demux, if n number of output is there, the number of select lines is m, where n is equal to 2 power m. Suppose if you have the output is equal to 2. Now what will be your m? M will be equal to 2 power m will be equal to 1, right? 2 power 1 is equal to 2, one select line. If you have 4 outputs, if n is equal to 4, now what will be your m? M will be equal to 2, right? 2 power 2 is equal to 4. So for your n is equal to 4 output, your select line will be equal to 2, that is m is equal to 2. Suppose if your output is equal to 8, if n is equal to 8, then what will be your 2 power m is equal to 8, what will be your m? It will be equal to 3. So m is equal to 3. So number of select line is equal to 3 for the case that if your output is equal to 8. Okay, so this is how you have to design your circuit. So this is your overall block diagram where you will be having one input and n output with m select line, and you can take an enable. There is one additional input which is called as an enable input. In this case it is taken as active high. Okay, means what? If enable is 0, you will be getting output as 0. If enable is 1, you will be having the circuit to be operated. Okay. Now let us consider an example 1:4 demux. So what is your input? Input is equal to 1 and output is equal to 4. So 1 input, 4 output. In addition, you will be having an enable pin also. Now what will be your truth table? Truth table, your output will depend on your select line. So how many number of select line is there? So S0, S1, 2 select line, right? So 2 power 2 is equal to 4. So n is equal to 4, m will be equal to 2. So m means your select line, S0, S1 is equal to 2, 0. So what will be your combination? 0, 0, 0, 1, 1, 0, 1, 1. When you have the select line as 0, 0, your output will be across your Y0. Okay. Y0 will be 1, all other will be 0. Similarly, when you have 0, 1 as your select line, your output will be across your Y1. Y1 will be selected. You will be getting the data will be passed to your Y1. All other cases it will be 0. If it is 1, 0, your Y2 will be selected. Your output you will be getting across your Y2. All other will be 0. If both are high, if both the select line is 1, 1, you will be getting the output across your Y3, right? So now how will you write the expression? What will be your Y0? Y0 will be equal to S1 bar into S0 bar into your data. Data is common to all, right? So D. Similarly, what will be your Y1? S1 bar S0 into D. Okay, so this is your expression, Boolean expression. Then how can you draw your logic diagram? So you will be having, it is a multiplication, right? So you will be having 4 number of outputs. So you will be getting 4 AND gate. And you will be having the data input which is common for all the AND gate, right? This data will be connected to all the AND gate. And what will be your expression? So S1 you will be getting, if you have to draw the two select lines, let us consider this is S1, then if you want to get S1 bar complement, then you have to use a NOT gate. So this value will be S1 and here it will be S1 bar, right? So what will be your first expression? Y1 is equal to S1 bar S0 bar into D. So D already you have given, now you have to give S1 bar S0 bar. Similarly, what will be your second? S1 bar, right, S1 bar and S0. Next you will be getting S0 bar, S1. Last you will be getting both will be high. So this is how you have to design a demultiplexer. Okay, so one of the commonly asked question for university is 1:8 demux. So what will be your block diagram? How will you have to draw your block diagram? So 1:8 demux. Okay, demux. So what will be a number of output? 4, right? 8. So you will be getting Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, and here you will be having single input. If I take this as D, what will be a number of select line? S0, S1, S3, S2, 3 select line. So M is equal to 3 and N is equal to 8. So this is going to be your block diagram. You can give in additional enable pin also, which is active high. Now how will you design your truth table? So if this is your truth table, what will be your input? I can write as enable. Then you have S1, S2, S1, S0, 3 select lines. Then you have 8 number of outputs, right? Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So how will be your output? If enable is 0, no matter what is your select lines, okay, your output is going to be 0. So for all the other cases, the enable is going to be high. So what will be your combination? 3 bits, right? So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So enable will be high in all the cases. So what will be your output now? When your select line is 0, 0, 0, you will be getting the data across your Y0. All other cases it is going to be 0. When it is 0, 0, 1, you will be getting the data across Y1. All other cases it is going to be 0. Similarly, so for 0, 1, 0, you will be getting the output across your Y2. All other cases it is going to be 0. The third case you will be having, that is 0, 1, 1, you will be having the data to be in the Y3. All other cases you will be getting 0. For 1, 0, 0, you will be getting the data output will be across Y3. All other cases it is going to be 0. For 5, 1, 0, 1, your data output will be in Y5. Similarly, for 1, 1, 0, the data output will be across your Y6. And the last case, when everything is high, your data will be across your Y7. So this is how the circuit works. Now going on to your logic diagram. So how will you draw your logic diagram? So let me take the input as data. Now you have 8 outputs, right? So you have to give 8 AND gate. So what will be your expression? 1, 2, 3, 4, 5, 6, 7, 8. What is your logic expression? Y0 will be equal to S2 bar, S1 bar, S0 bar into D. Similarly, Y1 is equal to S2 bar, S1 bar into S0 into D. Y2 is equal to, what will be your Y2 in this case? Y2 will be equal to S2 bar, S1, S0 bar, so on till your Y7. Okay, so similarly you can write here Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So first case it is 0, 0, 0. So S2, S1, S0. Everything is complement. 0, 0, 1, right? Second one. So S2, S1, 0, 0, 1. 0, 1, 0. So 0, 1, 0. Okay, complement. 0, 1, 1. So S2 bar, S1, S0. 1, 0, 0. So S2, S1 bar, S0 bar. 5 is 1, 0, 1. So what will be your 1, 0, 1? S2, 0, S1 bar, S0. Y6 is 1, 1, 0. So S2, S1, S0 bar. What is your Y7? 1, 1, 1. Everything is high. S2, S1, S0. So what will be your common factor? Everything, you will be having your data in, right? So now you can connect all the data into all the AND gate. So this will be your first step. Okay. So we will finish off this connection. One of the input to the AND gate will give, and what are the next two inputs you will be having? One is S1 and the other one is, sorry, three inputs, right? S2, S1 and S0. So if you want a complement of this, you will have to add a NOT gate. So this is going to be your S2 line, and you will be having a NOT gate, and this is going to be your S2 bar. Similarly, here you will be having S1 and you will be having a NOT gate which will give S1 bar. Similarly, you will be having S0, you will be having a NOT gate which will be your S0 bar. So here in this case everything is complement. So S0 bar, S1 bar, S2 bar. This is how you have to give the connection. For Y1 you have already given D. Now S2 bar, S1 bar, S0. So S2 bar, right? S2 bar, S0, S1 bar, but it is S0. So you have to take it from S0. Similarly S2 bar, third one. So here again it is S2 bar, S1. So you have to take it from here, S1, then S0 bar. So S0 bar. Similarly S2 bar, S1, S0. So S2 bar, S1. Where is your S1? So this is your S1 and S0. So similarly you can finish it off for your Y4, Y5, Y6 and Y7. Y4 it will be S2, S1 bar, S0 bar into D. Similarly Y5 it will be S2, S1 bar, S0 into D. Y6 is equal to S2 in S1, S0 bar into D, and Y7 is S2, S1, S0 into D. So if it is asked for 8 marks, you have to draw the block diagram, your truth table, logic expression as well as your logic diagram.